You've seen them everywhere, right? These absolutely stunning, sometimes bizarre images created by AI from just a few words of text. It seriously feels like magic. Well, today, we're going to pull back the curtain and show you exactly how the trick is done. Yeah, these images just pop up all over the internet, looking like they were conjured out of thin air. But spoiler alert, it's not magic. It's actually a really brilliant process, and it all starts with a simple creative challenge for the AI. Something kind of like this. Okay, so just look at this prompt. We're not just asking for a cat, we're asking for a whole vibe. It's gotta be photorealistic, cinematic. It needs a glowing wizard hat and ancient books. I mean, this is a seriously creative request. How on earth could a machine possibly understand all that nuance? And yet, from those few words, we get this. A totally new, completely original image that somehow nails every single one of those details. So, that brings us to the big question. How does an AI go from a string of text to a complex, beautiful picture that it has literally never seen before? Wow, this amazing ability is all part of a field called generative AI. See, unlike other AI that just analyzes or sorts data that's already there, generative models create something brand new. Our little wizard cat isn't just some copy-paste collage. It's a one-of-a-kind creation, and it's made possible by something called a diffusion model. All right, this is where it gets really, really clever. The core trick of a diffusion model is basically a two-step process. First destruction, then creation. The AI actually learns how to create an image by first learning how to completely destroy one. I know, it sounds totally backward, right? But stick with me because this is where the genius is. So first up is the forward process, or what I like to call destruction. The AI gets trained on millions and millions of images, and in this phase, it learns how to take a perfectly clear picture, like this one of a cat, and just systematically add a little bit of digital noise, step by step. It keeps doing this until the original image is completely gone. It's just a screen of random static. By doing this over and over, the AI learns the exact rules of how a picture dissolves into total chaos. And now for the magic part, the reverse process. Once the AI has mastered destruction, it just learns to do the exact opposite. It starts with a fresh canvas of pure random noise and uses everything it learned, but backward. Step by step, it very carefully predicts and removes the noise, and a real coherent image starts to appear. But here's the kicker. Notice it's not the original cat. It's a brand new image of a dog. This is what proves it's not just memorizing photos, it's genuinely generating something new from nothing. Okay, so the AI can make an image from noise. I get it. But how does it know to create our specific wizard cat? How does it follow our instructions instead of just spitting out something totally random? Well, this is where a couple of really key breakthroughs come into play. First off, we've got to talk about efficiency. Working with giant, full-sized images, pixel by pixel, would be incredibly slow. So models like Stable Diffusion use a clever shortcut called a latent space. Instead of messing with millions of individual pixels, the AI works on a much smaller, compressed idea of the image. It's kind of like an architect working with a simple blueprint instead of lugging around giant steel beams. It just makes the whole process way, way faster. But even with that shortcut, we still haven't answered the biggest question on the table. How do simple words, just plain text, actually steer this whole complicated process of turning noise into a specific picture? The answer is a really cool technique called classifier-free guidance. You can basically think of it as the AI's steering wheel. As the AI is removing the noise, that text prompt is constantly guiding its choices. At every single step, the model is essentially checking its work, asking itself, is this getting me closer to a photorealistic ginger cat wearing a wizard hat? This guidance is what steers the creation process away from being random and pulls it directly toward the specific picture we asked for. It's what gives us all that creative control. So this incredible technology isn't just some theories stuck in a research lab. It's the actual engine powering some of the most popular AI image tools that we're all using today. So let's take a look at how this plays out in the real world. Two of the biggest names in the game right now are Stable Diffusion and DALL-E 2, and they have really different approaches. Stable Diffusion is open source, which makes it super flexible and a huge favorite for developers and hobbyists who love to get under the hood and tinker. DALL-E 2, on the other hand, is a much more polished, controlled product from OpenAI. It's famous for spitting out incredibly realistic images right out of the box, which makes it awesome for professionals who just need top-quality results fast. Really, the choice between them boils down to how much control you want versus how much convenience you need. For a long time, the race in AI felt like it was all about size. Who could build the biggest model with the most parameters? But recently, that thinking has started to change. It turns out the future isn't just about getting bigger, it's about getting a whole lot smarter. This whole shift was kicked off by a groundbreaking research paper about a model named Chinchilla. The researchers there discovered a surprisingly simple rule. To get the best performance, when you double a model's size, you should also double the amount of data you train it on. To put it simply, a bigger brain needs way more books to read to actually get smarter. And the takeaway from this is huge. It means that a smaller, more efficient model that's been trained on a massive, high-quality dataset can actually outperform a gigantic model that was basically undertrained. The Chinchilla model proved this by beating models that were way larger. So now, the focus in AI is shifting from just raw size to the quality and the sheer quantity of training data, which is a much more efficient way to move forward. So there you have it. We've gone from random noise to an intelligent, guided process that can create absolutely breathtaking art from just a few words. This technology is getting more powerful and more efficient every single day, which leaves all of us with a really fascinating question to chew on. As the act of creation itself becomes more and more automated, what's the future of human creativity? What will that even look like?